All right, 7th graders, good morning. It is Thursday. We are ready for lesson 12 on page 49. Today, I do not have my sidekick with me to help me make my videos, so you may see a little bit of a stopping and starting, hesitation between, but that's all right. We can do this. All right, so lesson 12 is understanding scientific notation. Scientific notation is sometimes used to shorten very large numbers with many zeros or very small numbers with many decimal places. Here are some examples. And you guys have done scientific notation before. And remember that we talked about this exponent often will tell you, not often, it does tell you how many zeros to add. So you've got 4 and, well, this is supposed to be 15. 4 times 10 to the 15th power. Remember we say power. So you would say 4 and you would add 15 zeros. All right, so you start with 4 and add 15 zeros. You're moving your decimal point. Your decimal point is right there. And what you're doing, you're actually moving it 15 places out here to the right. Same with this. We've got 5.5 and we need to move it 9 places or add zeros. So we would move it 1 and then we'll add 8 zeros because we're already moving it here 1 place, 1, and then 2, 3, 4, 5, 6, 7, 8, 9. Move it out 9 places. All right, and if we want to do this one, this is a -3. Remember, negatives, you move it to the left. Positive exponents, you move it to the right. Negative exponents, you move it to the left. So we're going to move it 3 places to the left. 1, 2, 3. 0.0038. All right, so let's try some that you have on your book. The first one is 4.5 times 10 to the -4th power. All right, 4.5 times 10 -4. All right, you're moving it 1 place and then you're going to add 1, 2, 3 zeros. So you're moving it 1, 2, 3, 4 places. 0.00045. Number 1B, 7.06 times 10 to the 5th power. All right, so our decimal is there. So we moved it 1, 2, 3, 4, 5. So our answer is 706,000. 2A, 2.13 times 10 to the 3rd power. All right, so 1, 2, and we need to add 1 0. So you have 1, 2, 3. There would be your decimal point. All right, we'll do 2B yet. We have 4 times 10 to the -6. All right, so our decimal point is here. We need to go left. So we go 1, 2, 3, 4, 5. 1, we need to add 1, 2, 3, 4, 5, 6. So it's 0.000004. All right, you guys can do 3. Remember, positive goes to the right, negative goes to the left, and watch when the decimal is in the middle of the number. Don't add too many zeros or move it this way because you're already counting this and this as 2 decimal places, okay? Be careful about that. All right, just a little bit on your lesson. Page 50, number 13. You need to translate into an equation using n as a variable and then solve. You guys remember what quotient means? Abigail, what does quotient mean? It's the answer to a what problem? Division. That is right, division problem. So the quotient of a number and 5. So that's the answer of a number and 5. So if it's a division problem, the quotient of a number and 5 is equal to the sum. Seth, what does sum mean? It is the answer to a addition problem. Good. To the sum of 3 squared and 2. So 3 squared and 2. The sum of 3 squared and 2. All right, then you need to solve that one. Number 24 on page 51. Use the distance formula. Casey, you remember what the distance formula is? Distance equals principal times rate times time. Wrong. Distance equals rate times time. I'm sure you knew what that was. All right, so a trucker traveled across a sparsely populated landscape at 110 kilometers, that's your rate, for 2 hours and 20 minutes without braking or slowing down. How far did he travel on cruise control? Okay, you're finding the distance. The time is 2 hours and 20 minutes. This is what I wanted to help you on just a little bit. You have 2 hours and 20 minutes. Okay, you're going to have a fraction. Put your 20 over how many minutes are in an hour. 20 over 60, which is 1/3, okay? So it's basically 110 times 2 1/3, okay? And then you'll solve. One more thing on number 27. And maybe you guys got this. This just, y'all might be just fine. You can figure this all out. That's awesome. But I just know with the way we're doing school, if I can help you guys have less corrections, I want to do that. But I don't want to just give you the answers either. All right, do you guys know what these tick marks are? You know what tick marks mean when you see a triangle and there's tick marks? You know, you guys have done this already when there's a triangle and there's tick marks here. Remember, it means that they are the same, okay? And on your problem, this is all shaded here. This is 16, this is 24, and this is 8. What you're supposed to be doing is finding the area of the shaded part. So, what you're going to have to do, you're going to have to know this whole line is 24. So, if it's only shaded, well, when you come to find the area of this box, no, I'm sorry, you don't find the area of the box. You are going to find, you can do a trapezoid. Remember what the formula is for trapezoid? 1/2 times base 1 plus base 2. And this right here is a trapezoid. The problem is You have to figure out what that is because you don't want to include that in this. This whole line is 16. So if this line is 16 and this whole line is 24, so 24 take away 16 is 8. So you could say that this is 8 and this is 8. I shouldn't put that there because that'll confuse you guys. So if you want to figure out, use the formula for trapezoid for this one, 16 take away 8 is 8. So this is base 1 plus base 2, which this would be 16 and 8 also. If that helps you, you can either have 16 and 8 or you can think of it as all of 24. But those are the figures you're going to need to figure out the area of the shaded part. And you might have a way to figure it out on your own. Seth, you're usually pretty sharp at this kind of stuff. See what you can do. If you have any questions, make sure you give me a buzz. See you. Have a great day.